All right, so today we're going to talk about circles. We got done with parabolas, and one thing that we knew about the equation for a parabola is it said y equals ax squared. That was one form of the parabola. Or it said x equals ay squared. Okay, and in both of those equations, they were parabolas. They were U-shaped. They either opened up or down in this case, or they opened to the left or to the right in this case. And the reason that it was in that shape is because only one variable was squared. In the first example, the x is squared, but the y is not. And over here, the y is squared, but the x is not. So that's why it was a parabola. Okay, so now we're going to look at a circle. And we define a circle by the set of all points, x and y, in a plane that are equidistant from a fixed point called the center of the circle. To be equidistant means to be equal distance. So in a circle, we've got a center right here, and then all of these points that go around it, and that's not an accurate drawing, but all the points that go around it are the same distance from that center. If I were to measure the distance from the center to this point on the circle, it would be the same as the center to this point on the circle. And so every single point that's on this circle is the same distance from the center, is what it's saying. Okay, and we have a radius, r. The radius of the circle is the distance from the center to the outside of the circle. That's the radius. Remember, the diameter is the distance all the way across, but the radius is just from the center to the outside, and we label that with r. The standard equation of a circle is this right here. Notice that the center is at the origin. So the center would be at 0, 0. It would be in this form, x squared plus y squared equals r squared. Notice that the x is squared and the y is squared in the circle equation. Okay, so it says graph the given circle and identify the radius. And it gives a little hint here, rewrite in standard form first. So this particular equation, y squared, notice that x squared and y squared are on the same side of the equation in the circle equation. So we're going to move this to the same side. We do that by adding x squared to both sides of the equation. And when I do that, I write the x squared first plus y squared equals 36. Okay, so the center is at the origin. So 0, 0 is the center. And this value 36 is representing the radius squared. So if the radius squared equals 36, what is the radius? How would you solve that? Okay, well, I would take the square root of both sides. So the radius is going to equal 6. So when I go to graph that, I put the center here. Center's at the origin. And if the radius is 6, I'm going to count out 6 going up. I'm going to count out 6 units going to the right. I'm going to count out 6 units going to the left. I'm going to count out 6 units going down and to the left. So I give myself some points to shoot for. Now it's really hard to draw a circle. Do the best you can to create an arc that goes around and catches each one of those points. Okay, there's my circle. Again, it's not perfect, but do the best you can. Okay, in example B, this time it's the y that's over here. I'm going to add y squared to both sides. I want my x squared and my y squared to both be positive. So I'm going to add y squared. I would have x squared plus y squared minus 4 equals 0. I add y squared and I have 0. And I've got to take that 4 to the other side. So I'm going to add 4. So I'm going to have x squared plus y squared equals 4. Okay, that center is at 0, 0 again. And the radius squared now, that value is equal to r squared. That equals 4. So what does r equal? Okay, I'm going to take the square root of both sides, and I'm going to get a radius of 2. Okay, so I would just measure up 2 up, go 2 to the right, 2 down, 2 to the left, and I'm going to make that circle. Okay, do the best you can to make it a circle. Okay, the third example on here, the x squared and the y squared are on the same side, but notice that it's got a coefficient here of 4. in our standard equation, we needed to have ax squared plus y squared equals r squared. We don't have coefficients other than 1 there. So I'm going to take this and I'm going to divide both sides of my equation by 4. If I divide both sides of the equation by 4, I now have x squared plus y squared equals, this would be 32. So again, we've got a distance here. If r squared equals 32, when I go to take the square root of both sides, okay, you're going to have to use a calculator to find the square root of 32. I know the square root of 25 is 5, and I know the square root of 36 is 6. So let me grab my phone here, and I will use the calculator. I want 32, and I want to find the square root of it. I get 5.7. Okay, that's an approximate value. So I would just estimate. I'm going to go out here, look a little bit more than 5.5. There's 5.7 out here. 5.7. 5.7. Okay, so when you get a decimal like that, you're just going to estimate where it's at and then draw your circle in. Okay? Okay, it says write the standard form of the equation of the circle given the radius whose center is at the origin. So again, the center is at the origin, so it's going to be x squared plus y squared. Okay, when you don't see values here with the x and the y, it's at the origin, it's like 0. Okay, and this is the radius. So remember that this value here is the radius is r squared. So I'm going to put in here 8, but I have to square it to get the radius. So my final answer would be x squared plus y squared equals 64. That would be my final equation. Over here, this is the radius, so it's going to be x squared plus y squared equals the radius, but you have to square the radius in the equation. What's the square root of 15? And then when you turn around and square it, you just get 15. And the last one here, this is going to be x squared plus y squared equals 4 square root of 6 squared. Okay, how do we simplify that? This would be x squared plus y squared equals, we have to square the 4, and we have to square the radical here. So that would be 36, which is equal to 6. 16 times 6. This is going to be x squared plus y squared equals 96. 16 times 6 is 96. Okay, let's see what else we got here. It says, write in standard form the equation of the circle that passes through the given point and whose center is at the origin. So you're going to have to figure out if the circle goes through this point, but its center is at the origin. If I graphed a little, if I put this on a graph, just kind of sketched it here for you. Okay, we're saying that the center is here, and it's going to go through this -6 to 0. To go through that point. So you got to figure out what that distance is. What is that radius? Well, that tells me that the radius is equal to 6. So when I go to write my equation, I can say x squared plus y squared equals 6 squared, or x squared plus y squared equals 36. Okay, if you've got your circle here, this is at 0, 0, and the circle is at -6, +8. Let's say it's up here. This is at -6, +8, and this is at 0, 0. How are you going to figure out the distance of that radius? Okay, well, hopefully you think back to using the distance formula. That's one of the reasons why we showed you the distance formula in the beginning. The distance formula is equal to, okay, we're going to take the difference in the x values, 0 minus a -6, and we're going to square it. plus the difference in the y values, 0 minus 8 squared. And we're going to simplify that. Here we do leave, change, change. So this would be the square root of 6 squared plus, this would be a negative 8 squared. This would be 36 plus 64, which is equal to the square root of 100 is 10. So this radius, that distance is 10 units. Okay, now that I know what r is, I can go ahead and write my equation. X squared plus y squared equals 10 squared, the radius squared. So x squared plus y squared equals 100 would be the equation that I'm looking for. Okay, and you're going to have to do the same thing over here. You're going to have to find the distance between the center, 0, 0, and that point on the graph. Once you're able to locate that distance, that will be your r value, and then you can plug it into your equation. Okay, once you give that a shot,